हेलो बच्चों, लेट अस रीड दिस क्वेश्चन. अकाउंट फॉर द फॉलोइंग ऑब्जर्वेशंस. यहाँ पे 4 स्टेटमेंट दिए हैं हमें. उसमें स्टेटमेंट करेक्ट सही कौन सा है हमें बताना है. चलो, लेट अस सॉल्व दिस क्वेश्चन. फर्स्ट ऑफ ऑल we'll see this AlCl3. AlCl3 is Lewis acid. Correct statement. लुईस एसिड क्यों होता है? व्हाट इज लुईस एसिड? फर्स्ट, लुईस एसिड इज an electron pair accepted. So it accepts an electron pair because aluminum has a vacant orbital in its outermost shell. A vacant p orbital is there. So in here it forms only 3 bonds. यहाँ पे 3 bond form करे हैं. So each bond contains 2 electrons. इसके पास 6 electrons ही हैं. So every atom try to get 8 electrons, right? Here 6 only there, so it readily accepts 2 electrons. Nothing but a pair of electrons. Therefore, AlCl3 acts as Lewis acid. So ये statement सही है. Next, B statement देखेंगे. So B statement में क्या दिया है? Though fluorine is more electronegative than chlorine, at BF3 is a weaker Lewis acid than BCl3. सबसे फ्लोरीन मोर इलेक्ट्रोनेगेटिव है, मगर BF3 में लुईस एसिड से एसिडिक स्ट्रेंथ कम है. क्यों? सो लेट अस सॉल्व दिस. इन BF3 this is sp2 hybridization, planar shape. Already it forms 3 bonds. So boron has how many electrons? Only 6. So it is a deficit of 2 electrons. So this has, like aluminium, boron also has vacant p orbital. This is vacant 2p orbital. In case of fluorine, it has filled p orbitals, means having electrons. So I'm showing you this with the orbital with filled electrons. So this is also 2p subshell. What will happening? Back bonding takes place. After the sigma bond formation, the pi bond character is developed between this. So ये vacant orbital अब नहीं है, तो उसका already electrons occupy कर रहा है. So it is not act as an electron pair acceptor. Whereas in case of BCl3, BCl, Cl, Cl. Okay, this is also having vacant p orbital and chlorine having filled p orbital. So this is filled p orbital of chlorine. Okay, now this is see the back bonding tendency here. This is 2p orbital, chlorine atomic number 17. So its configuration 1s to 2s to 2p6, 3s to 3p. Means this is 3p orbital which is in the outermost shell. So here back bonding ability less compared to this one. So as back bonding is less, it is ready to accept an electron pair. So that's why BCl3 is having more Lewis acidic character compared to the BF3. Because of back bonding, this BF3 unable to accept electrons. So hence it is weaker Lewis acid. ये B point है. So C point देखेंगे अब. So in C point what is given? PbO2 is a stronger oxidizing agent than SnO2. Okay, if this is Pb and Sn belongs to the group 14 elements. In group 14 elements, the outermost electronic configuration is Ns2 Np2. So there are how many electrons? 4 electrons are there, right? Like this, 1, 2, 3, and 3, and this is 4. Right. Next, see this from top to bottom, what will happen? The +2 oxidation stability increases and +4 oxidation stability decreases. Sn shows +2 and +4, but Sn +4 is more stable. So is here Sn +2, SnO2, Sn is having +4 oxidation state, which is already stable. Whereas Pb shows 2 oxidation state, Pb +2 and Pb +4, but Pb +2 is more stable. The reason behind this is inert pair effect. Inert pair effect. So because of inert pair effect, it is possible only in the large sized atoms of p block elements. So the outermost s electrons tend to pair up and they do not involve in the bond formation. So this is called inert pair effect. So because of inert pair effect, Pb plus 2 is more stable. So PbO2 is in the plus 4 oxidation state. It can readily changes into PbO in Pb, that is plus 2 oxidation state. Why it is readily changing into that? Because it is stable. Pb plus 2 is more stable. Why it is more stable? Reason, inert pair effect. So plus 2 to plus 4 to plus 2 it is changing means it is a good oxidizing agent. So what is an oxidizing agent? Oxidizing agent is a one which oxidizes others, reduces itself. Itself reducing plus 4 to plus 2 and oxidizing the others. It is giving oxygens to the others to oxidize. So therefore, Pb plus 2 is a stronger oxidizing agent than SnO2. The reason is inert pair effect. That is possible only in the case of PbO2. Inert pair effect is not possible in case of Sn. The inert pair effect is possible only in the case of Pb. Now, this is the statement C. And now statement D. We will see. Now, in statement D, what is given? This the plus 1 oxidation state of thallium is more stable than plus 3. Same, just like this lead. Lead is in the group 14 elements and thallium is in group 13 element. In group 13 elements, thallium is the last element, means before the lead only thallium is present. So thallium outermost configuration also it is Ns2np1. So it readily showing plus 1 oxidation state by losing these electrons, and s electrons are tend to pair up and they do not involve in the bond formation. So thallium readily shows Tl plus 1 than Tl plus 3. That is, the reason is inert pair effect. So inert pair effect is the reason for thallium plus 1 oxidation state is more stable than thallium plus 1. What is inert pair effect? Outermost s electrons are tend to pair up and they do not involve in the bond formation. In case of large sized atoms of p block element, it is one of the consequence of lanthanide contraction. Okay, so because of inert pair effect, Tl plus 1 is more stable than Tl plus 3. Okay, so these all are, whatever the statements given, all are correct. And they are account for the following observations. See, all these observations, whatever they gave, all these are correct. Okay, and we A and B, C, D, all the points we completed, we covered. Hope you understood. Good luck.